Alright, so this is for the part A of the stoichiometry video retake. And yeah, so you're supposed to choose any double displacement reaction. So here's mine up here. AgNO3 plus NaCl yields AgCl plus NaNO3. So we have our 3 molar of the first reactant, 4.5 molar of the second reactant, and 5 grams precipitate. So we're going to start off here with the 5 grams of AgCl and multiply that by 1 mole over the molar mass. From there, we're going to convert to moles. So we'll take 1 mole of NaCl and put that over 1 mole of AgCl. And it's 1 and 1 because the coefficients are 1 and 1 up in the balance chemical equation. So this is all 1, so it's 1, 1, 1, 1. And yeah, so we're going to get that. Then we're going to use the liters over moles for, so what that means is like for every 1 liter of NaCl, there's 4.5 moles of it. And then finally, we're going to change it into milliliters, which we need over here. So we're just going to go ahead and use 1,000 milliliters of NaCl over 1 liter of NaCl. And that will get us 7.8 milliliters of the 4.5 molar solution. And now we're going to do the 3 molar solution. So we're going to do 5 grams of AgCl and do the same molar mass thing. So molar mass underneath the 1 mole of AgCl. Next, we're going to convert to moles of AgNO3. So we're going to have 1 mole of that over 1 mole AgCl. Do the same thing that we did up here, just down here. So this means for every 1 liter of AgNO3, we have 3 moles of AgNO3. And finally switch it into milliliters again, which we're going to use for the final equation down here. So we're going to do 1,000 milliliters of AgNO3 over 1 liter of AgNO3. And this will give us 11.6 of the 3 molar solution. And finally, we're going to find the moles of our new substance, which is this one right here, the NaNO3. So we'll come back down here. We have 5 grams of AgCl, and we're going to do the molar mass again. And like I said earlier, all the coefficients are 1. So converting from AgCl to NaNO3 is just going to be 1 over 1. And so when we do all this, work it out, we get a 0.034887 moles of NaNO3. So molarity is moles over liters, so moles over liters. And so for liters, I've rounded both of these to make an even 20 that we're using down here. So this is 7.8 rounds up to 8 and 11.6 rounds up to 12. So 12 plus 8 will give us 20. So 20 divided by 1,000 underneath 0.034887 gives us 1.7 m. So that means our NaNO3, our new substance, is 1.7 molar. Alright, so for the second part of the equation, we were supposed to react 50 milliliters of the 3 molar solution with 11 milliliters of the 4.5 molar solution. So then we're going to have to identify limiting and excess reagent, calculate excess reagent left over milliliters, figure out what our percent yield would be if we measured 6.4 grams of precipitate, and then do an error analysis. So first, I converted these into liters, these two, so we have 0.015 and 0.011. Next, we're going to multiply the liters from here by molarity. That'll get us 0.045 milliliters of AgNO3. And then we're going to do the same here for NaCl, so times molarity 4.5 over 1. That'll get us 0.0495 NaCl. And so down here, or from here, we can see that AgNO3 is the limiting. And so we're going to take our limiting, and we're going to take the 0.045, and we're going to convert it to AgCl. So we're going to multiply it by 1 over 1, and then the molar mass, to see that we have 6.4 grams of AgCl produced. So we'll bring it down here. And so we have 6.4 over 6.44945. And this one is, this one right here, I just rounded the 4 down. So we had 6.4. But yeah. So we'll multiply that by 100, and we get 99.2% yield. And our error could have been in measurements or in the math, but it was a pretty minute error if we had one, because you can see we're very close to 100, about 0.8% away. So finally, we're going to take the 0.045 moles of AgNO3 of our limiting reagent and convert to moles of AgNO3 down here. We're going to multiply that by 1,000 milliliters over 4.5 moles, which is molarity, and we're going to discover that we have 10 milliliters of NaCl used. So, but originally up here you can see we had 11. So if we go ahead and 11 of our original, from given in the equation, minus our 10 that we actually use, we get 1. That will be 1 milliliter of excess NaCl. Alright, so finally, we're supposed to pretend that one of our products is actually a gas and calculate how many molecules of the first 3.0 molar solution are required to produce 5.8 liters of gas. So here's our equation here, and here is our gas, the AgCl. So we're going to take 5.8 that we need to produce, and multiply that by 22.4 liters of AgCl underneath 1 mole, and then we'll convert to AgCl, which is 1 over 1, because our equation is 1, 1, 1, 1 again. And finally, by Avogadro's number to find molecules over 1 mole of AgCl, and we get 1.6 times 10 to the 23rd of AgNO3 required to make 5.8 liters of AgCl.